You are driving at 100 km per hour. In just milliseconds after a crash, a hidden system inside your car explodes a balloon right in front of you and saves your life. But have you ever wondered how your car knows when to deploy the airbag? Today on Real Time Tech, we are diving into the incredible world of crash sensors, accelerometers, and the fast speed electronics that decides life or death. We will break down every step of this real-time system, from sensing impact to deploying the airbag, and explore the critical role embedded electronics play in making it all happens under 30 milliseconds. Get ready to witness electronics in their most high-snake applications ever. What is airbag? Airbags are part of your vehicle's supplemental restraint system or SRS. While seatbelts are your first line of defense, airbags are your second. They deploy only when needed, like during moderate to severe frontal collisions. Inside the steering wheel, dashboard, and even side panels, airbags are tightly folded and connected to sensors and the control unit. Their job: inflate within milliseconds to caution the driver and passengers, preventing contact with hard surfaces like steering wheel, windshield, or dashboard. Modern vehicles can have multiple airbags, including curtain airbags, side impact airbags, and even knee airbags. Crash sensor and accelerometer. The brain of the airbag system begins with crash sensors, often MEMS-based accelerometers. MEMS stands for micro electromechanical systems, tiny chips that measures acceleration forces. These sensors monitor how fast the car is accelerating or decelerating in real time. In normal drive, you slow down gently for traffic or speed bumps, but in a collision, the deceleration is massive and sudden. When it crosses a certain threshold, usually around 50 G, it signals that a crash has occurred. This signal is instantly sent to the airbag control unit or ACU, where decision making happens. Often, multiple crash sensors are placed in different parts of the vehicle, including the front bumper and door sides and etc. The ACU compares all this data to determine the severity and type of collision. Timing is everything. The ACU must make a life or death decision in less than 30 milliseconds. That's faster than the time it takes to blink. This is where real-time embedded systems shine. The control unit runs interrupt-driven firmware, constantly checking sensor data. When a crash is detected, it enters an emergency logic flow, evaluating data across multiple axes and time samples to avoid false positives. The system is built with redundancy. Some units use dual-core microcontroller units to cross-verify data. Others include watchdog timers that resets the processors if it hangs during execution. Power loss backup circuits ensure that even during battery failure, a small capacitor or backup battery can still deploy the airbags. There are also self-diagnostics. Every time you start your car, the system runs tests on the sensors, circuits, and igniter paths. That's why you see the airbag warning light briefly. It's confirming the system is healthy. Real-time logic is not just fast. It's reliable, deterministic, and designed to never fail in a critical moment. Detonator circuit. Once the decision is made, it's time to action. The ACU sends a high current pulse to a device called squib, a small resistor-based igniter. The squib heats up rapidly, igniting a chemical propellant, usually sodium azide or modern replacements like nitrate. The resulting explosion creates a large volume of nitrogen gas, which inflates the airbag in around 30 to 40 milliseconds. Sometimes it's less than 30 milliseconds. This inflation is so fast that by the time your body begins moving forward due to inertia, the airbag is already fully deployed and in place to caution the impact. The bag also has tiny vent holes to deflate slowly and absorb your forward motion, preventing rebound injuries. This entire process from crash detection to fully airbag deployment takes less than the time it takes to snap your fingers. Event data recorder. After the airbag deploys, the system doesn't stop. It stores everything that happened in an event data recorder, also known as the car's black box. This includes time of impact, vehicle speed, brake usage, airbag deployment status, sensor readings. This data is crucial for an accident reconstruction, legal cases, and improving car safety. It works like the flight data recorders in an aeroplane, capturing the final moments before and after the crash. These recorders are part of your car's CAN, controller area network, and communicate with other ECUs, ensuring that even after a crash, the data is preserved. So next time you buckle up, remember, beneath your dashboard is a team of real-time embedded systems working silently, monitoring your every move, ready to react in milliseconds. Airbags aren't just balloons. They are the result of precision electronics, mechanical engineering, and real-time embedded logic designed to save our lives. From sensors and signal processing to timing critical detonators and data logging, it's a masterpiece of engineering. If this breakdown opened your eyes to the tech that protects you, give this video a like. Share it with your friends who love cars and tech inside the cars. And if you are into embedded systems, sensors, or real world electronics, subscribe to our channel for more videos on real time tech that decodes the tech happening behind the scenes.